All right, there we go. So we're going to be talking about another example on normal distribution and how to use the probability and the area. So in this one, it says, in order to qualify for a medical study, an applicant must have a systolic blood pressure in the 50% of the middle range. If the systolic blood pressure is normally distributed with a mean of 120 and a standard deviation of 4, we're going to find the upper and lower limits of the blood pressure a person must have in order to qualify for the study. All right, the process that we'll do here, when it's asking for, I guess, to draw this out. So if we draw this out in step one, if I want 50% of the middle data, that would be this part right here. 50% of the data. So this is the part I want. All right. My mean here was 120. Right. And then that means that there's 50% still left. So that's 25% on both sides of the data, right? So that's basically the area under the curve. So the area here that I'm not going to shade is going to be 0.025. Oh, my bad. Just 0.25. And the area over here that I'm not going to shade is going to be what? 0.75, right? That would be what that area would be, and then we would subtract it. So I need to find out what the area at 0.25 is and what the area at 0.75 is to figure out what the z-score is, to figure out what the how many standard deviations I'm away to calculate that. So using our chart, let's go find out what has an area of 0.25. Charts are in our textbooks. 0.5907. 0.598. It's like solid. Okay. Do I have a second on that? Well, that's what, oh, sorry, that's what I want. I want the z-score. Yeah, you need to look at the, oh, I don't, so the 0.25 is not the z-score. 0.25 is the area. So you need to go find 0.25 and then tell me what the z-score is. Negative 1.96. Negative, that definitely sounds a lot better on the left side of the mean. Can I get a second on that? Negative 1.9. Okay. Then I need to go find the area that has 0.75. That should be in the positive side. Oh, yeah, I want 0.25. Definitely going to be a negative. So we got, okay, so what was the, so it's what it's closest to unless it's dead in the center.
Okay, yeah.
So that's 0.017, that's 0.14. I think the 2.514 would be closer. So that would be negative 0.67. So this would be negative 0.67. Good, that's what they calculated. Now I'll go find the area at 0.75. Right, which is what we kind of saw in the previous examples. All right, so now that we have our z-scores, now we got to go calculate what our x value is. If you recall, the equation they got for the x value was x equals standard deviation times the z-score plus the mean. Yeah. So now that we have our z-score, we have the mean, we have the standard deviation. Now we can go calculate our answer. So the standard deviation was 4. That's going to be 4 times the z-score of negative 0.67 plus the mean, which was 120. So what is 4 times negative 0.67? And Charlie, if you need to stand up again, I'm totally okay with that. Oh, okay, gotcha. I was like, that was fast because you literally just walked over here and walked over there. It's okay. I get it. I have to close my eyes to see the. No, I feel it's just me. Yeah. I've heard that before. It's not you, it's me. Yeah. One more time. The name of the table is Appendix A Table E. Yes. Yeah, table. I think it's Appendix A, Table E. Yeah, that's the little chart that you'll get to use on the test. So it has all the formulas on it as well. Oh, I don't know. That sounds about right. Yeah, that's about right. All right, now add the 120 to it. Well, that was a negative 117. Good. Good job, no calculator. All right, and then do the next one, which will be 4 times positive 0.67 plus 120. And what's that give you? There you go, 0.68. Yeah, you're good. All right, so that means to qualify for this systolic blood pressure application, they have to be between 117.32 and 122.68. That's kind of very specific there. Mhm. Any questions on that? Mhm. All right, so then let's go ahead and talk about that last topic of normality. Does everyone have this? So all this work goes to like step 2 and step 3. You can add in where you need to. I just didn't feel like scrolling down. Like right here, you'd put in your work. All right, so normality. So there are a variety of ways to determine if a distribution of values is normally or approximately normally distributed. The easiest way to check for more normality is to draw a histogram. If you recall a histogram, it is vertical bars that touch, right? For the data and check its shape. So I would want to see something that looks kind of like this. Give or take, on even a bigger scale if you wanted to do that. Right? But it makes that unimobile bell-shaped curve. Right? Another is to find the Pearson coefficient. They call it PC. I've actually seen it as the R as well, so you might see that as well. Of skewness for the Pearson's index of skewness, which is going to be 3 times whatever the mean is, but this is the sample mean. Notice it's no longer a mu, minus whatever the median is, divided by the sample standard deviation. Again, do realize that these guys right here are sample. Yeah, but not for population. So it looks like it's taking a sample out of the population to indicate if it is a normal distribution or not. Mm-hmm. So if the index is greater than or equal to +1 or less than or equal to -1, it can be concluded that the data are significantly skewed. So we want to find something that's between 1 and -1. So if it is 1 or greater or -1 or less than, then it's going to be skewed in a way that's pulling the data positive or pulling the data negative. I will say, preparing for this class I didn't get to teach at Lamar, I did make PowerPoints. So the next time I'll teach this, it won't be so much packet. Or do y'all like the packet? I can't tell. Yeah. Yeah. Would a PowerPoint of me doing it, going with the packet, work better than just doing it as a fill-in? I don't know. Yeah. True. Yeah. Well, the way I was going to teach to them, I wasn't going to give them the packet at all. I was just going to give them like the ability to print out the PowerPoints if they wanted to make notes on it, type thing. I don't know. Sometimes to me, I feel like this might be a little boring and not very interesting by just filling in blanks and stuff. So I don't know. Yeah, well, I took the examples, I just put them on a PowerPoint and then worked them out. So a lot of these, I like it, but a lot of these examples were already worked out for us. So I feel like I'd rather go over it with you than rather than going, hey, we did this, this, and this. Because here, as a student's mindset, if it's already worked out for me, I'm not going to do the work because it's there. So like we did it together, and we just verify that we got the right answer. I don't know. I don't know. That was just my opinion. Um, in a bigger class. Well, I will say the largest dual credit class I've ever taught was 10 kids. So that's, I mean, there's not many that qualify. Either or say there's not many that qualify, and the ones that do qualify don't always want to do a dual credit math class. They usually want to do their Englishes and histories and the fun classes. All right, so that was just a little random thing in my head that just popped up. All right, so what we're going to do though is to see if it's skewed, then we'll check the data for outliers by finding the outlier boundaries. We did this in a previous unit. I think it was actually unit 1, or not unit 1, unit 3, as defined by these guys. So if you recall, we found our IQR multiplied by 1.5, and we subtracted it by the first quartile and added it to the third quartile. And if you forgot to find IQR, it is the third quartile minus the first quartile, which I believe now all those formulas are on your chart. So I think that might be a little bit easier for you to approach. All right, so any questions so far? All right, let's do an example. I think this might be our last example, maybe. All right. So technology innovation. So it says a survey of 18 high-tech firms showed the number of days inventory they had on hand. Determine if the data are approximately normally distributed. So here's the data. So we want to determine if it's normally distributed. It didn't tell us if it was. So we need to construct a frequency distribution so that we can draw a histogram. So this is again going from unit 1 on producing this. So we want to produce classes. Do you remember how many classes you have to have? What's the number between 5 and 20? All right. So let's figure out what our range is first. What's the largest number? 158. Is it in order? Sweet. All right. 158 and then 5. What's that give me? All right. What could I probably divide that evenly into between 5 and 20? Well, I know it's divisible by 3. So is it divisible by 6? No. 9? Yes. Yes, it is divisible by 9. Oh, let me just show you. I don't know. I think I've done this before. Do y'all know how to figure out if something's divisible by 3? You just have to add up all the numbers. So 1 plus 5 plus 3 is 9. Is 9 divisible by 3? Then this one will be divisible by 3. So, and to do that, 3 goes into 15 how many times? 3 goes into 15 5 times, right? And then 3 goes into 3 how many times? So this actually goes into it 51 times. So if 3 can go into it, then potentially multiples of 3 can go into it. So I then went with 6, but 6 goes into 15 2 times the remainder of 3, but 6 doesn't go into 33. So then I was like, all right, well, does 9 go into it? 9 goes into 15 one time. Yes, sir. And you're trying to see if it's divisible by 3? Okay. Yeah. Yeah. You can keep doing that until you get to a number you like. But as long as whatever the sums are, if it's divisible by 3, the whole thing will be divisible by 3. All right, so then I tried 9. 9 goes into 15 one time with a remainder of 6. And then 9 goes into 63 7 times. So I can see 9 can go into 153. So I'm going to divide this by 9 to see how big my classes will be. So again, we just did that math. That would be 1. Oh, you're right. Then it'd be 2 per class. Well, maybe. Yeah, well, it told us there's 18 too. But you're right. So I wonder. Let's do it. Let's find out. Let's see. We might have to do this twice. So that'd be 17. So our class, let's let our classes be 17 width wise. So class will be 5. And remember we don't add 17 to this. We would add 16 to this. So what's 5 plus 16? 21. I don't know why I'm doing 5 plus there. 5, 2, 21. Now, recall that's still 17 numbers, right? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There's the 7. I don't know why I got stuck over here. But then there's 17 numbers, right? So then I'll do the same thing. This will then start at 22 because there can be no overlap. Add 16 to that, and you get, I don't know why I keep putting the adding sign, 38. And then I would go to 39, add 16 to that. Go to 56, add 16 to that. Sorry, my brain went somewhere. All right, so 73 goes to what? And then 90 goes to 106. And then 10, running out of room here. I can't pull it. Do it. I'm writing on top of the screen. Yeah. It'd be different if like I was writing on this paper, but I'm not writing on the paper. It's like there's like a glass film on this, and I'm writing on that, and then I erase it and then move what's underneath. If you think of it kind of like that. Fred. Yeah, that'll work. I'm gonna do a class over here. So then that would be 107 to then 124 to then 141 to why'd that not work out? So we should have landed right back on 18 or 158. But then we would have 10 classes then. 1, 2, 3, 4, 5, 6, 7, 8, 9. We decided to go with 9 classes with 17 as the width. Nope, it didn't. Hmm. Do what? How what? I don't know. That should have worked out perfectly. Well, I guess we could do 10. Doesn't really matter. 158 to what's 16 more of that? 174. All right, so we'll have 10 classes. As long as we're staying between 5 and 20. I think that data's not going to show us much. So Olivia, I think you might be right. That will end up with like 2 per little class here. So between 5 and 21, I can see that there's 1. 22 through 38, I see that there's 2. 39 through 55 is 2. 56 through 72 is 2. 73 through 89 is 4. Oh, okay, here we go. 90 to 106 would be 1, 2, 3. 107 to 123. 1, 2. 124 to 140 would be 0. 141 to 157 would be 1. And 158 to 174 would be 1. All right, so maybe not so much. We might be able to get something out of this. All right, so here's my first class. So here's 1, then 2, then 2, then 2, then 4, then 0, then 2, then 0, then 1, and 1. All right, so something kind of like that. So, well, go ahead. Is that a rule? I don't remember that being a rule. I just know that we had to have it to where everything went into a category. So all of our data did fall in, but we couldn't skip around. So like if we had nothing in that category, we did have to have a 0 as a placeholder. But I don't think we were limited. Yeah. I got 1, 2. I did write a 3, huh? It's just a bad 3. All right, so then 90 to 106 was the 1, 2, 3, 4, 5, 6 column. 1, 2, 3, 4, 5. There you go. Now there's only 1, 0. I just couldn't read my own handwriting there. All right. And then of course you would want to label these as your classes. So 5 through 21, 22, and so on and so on. I guess I should do that as best practice. I think I'm just going to do the boundaries. So 5, 22, 39, 56, 73, 90, 107, 124, 141, and 158. And this would wrap up at 174. Right? So I just did the lower boundaries on each one of them instead of doing the entire class. Alrighty. Okay, so we got our frequency there. We got our histogram. So we got it drawn out. And it says now. So looking at that, could you tell me if that's normally skewed or normally distributed? I think semi, but it does look like there's more data over here on the left. So I think it's going to be a right skewed. In my opinion, because the tail here over here, but that's just what I visually see. When it comes to graphing, I'm not a big fan because it could be my opinion's different from your opinion on skewness. But we are then left with a equation. So does everyone have this written down? So on the next part, it's going to have us use that Pearson coefficient. There's our histogram. Oh, you had room to draw it. All right, so this one says use the Pearson coefficient of skewness to determine if it does. So this will be 3. What was the oh, we didn't calculate the mean. Does someone want to calculate that mean? Add all 18 up and divide by 18? Yes, ma'am. Perfect, Malachi. Good job. I was trying to give you some credit. All right, so 79.5. The median can be calculated by going to the 9th and 10th number, which would be between 74 and 81. So how would I figure out the number that's going to be in the middle of that? Okay, so 74 plus 81 divided by 2 gives us 77.5. What was the number I just said? Good, I literally just forgot it. And then add it back. That seems like you're doing a lot more steps than adding and dividing. Because you subtract it, then add it. Oh, actually, you subtract it, divide it, then add it. Yeah. Yeah, I got you. All right, the S part is the standard deviation. Oh, that's so sad. They didn't give it to us. Oh. Yep. We're gonna pull up an Excel sheet real quick. We got this, guys. All right. I have not. What happened? Oh, I know. I said that during second period. I was like, gosh, it looks like some chickens got loose in there. There's feathers everywhere. All right, that looks like about 18 numbers. Standard deviation, we then had to do what? To get the mean, right? So average. Oh, we do have the, well, I'm just gonna cue the mean anyways. I guess it didn't calculate the average. So I have to spell out the whole average. I do. So 79.5. We then had to take it was X minus the mean, right? I got y'all's formula chart. So X minus the mean. Oh. Hmm? Mm-hmm. Yeah, I took from A and I subtracted it from this 79.15. We then squared it, right? And then we have to add it, right? We have to get the sum of that. Yeah. And then we had to take that answer, divide it by how many did we have? 18 high-tech film. This is for still be, no, I'm using I don't remember the shortcut. Yeah. So I would say 17 because this is a sample. So this is n minus 1. So that'd be 17. Gives us that. But that's the variance. So then I need to do the square root of it. Square root of this guy gives me 40.45. Remember how to do all that? Good stuff, right? All right, now that we got that answer, it was 40.45. So now we got to figure out what that is. I did all the work. Can y'all do this part? Thank you. Y'all just stared at me. And then divide that by 40.45. Mm-mm. I can get 6. Oh, well, you did the difference. And then you got to times the 3. What'd you get? Point. Yeah. 0.148. I'll stop there. So regardless, if I even kept on going with it being 0.148, does this indicate it's being skewed? No, because the number has to either be greater than 1 or less than -1. If it falls between 1 and -1, that would indicate that it is not skewed. So this is not skewed. So if it's not skewed, then we can assume it's normally distributed. Do apologize for the boring lecture today, guys. It does want to check for any outliers. I don't know why you would. If you indicate that you're normally distributed, I wouldn't do this next step. But it does have us do it anyways, maybe just for practice sake. So to find the lower boundary, remember it's going to be Q1 minus 1.5 times IQR. So we need to go find our IQR. That's an IRQ. Which again is Q3 minus Q1. So we need to actually go figure out what Q3 is. And Q1. So Q1 was 45 and Q3 was what? Good. Anyone have a second on that? Everyone agree with that? Okay. 98 minus 45 would be 53. So then I come over here. This is supposed to be Q1. So then I take 45 minus 1.5 times 53. And what's that give me? Negative 34.5, which definitely indicates that we have no outliers on the left side. Let's check the upper, which again, we should still get no outliers if we got a normally distributed outcome. So in this case, that would be 98 plus 1.5 times 53. What's that give me? And again, our largest number was 158, so we don't have any outliers on the right-hand side. So that very last sentence, it says now using the 3 indicators, the distribution we can now firmly say is normally distributed. So that last little blank there is normally distributed. Because you've seen it on a histogram, we argued that it looked pretty bell-shaped, right? It had a monomial. We saw that the Pearson's coefficient was between -1 and 1, and then we just saw there was no outliers, which also makes sense because there's nothing pulling the data left or right. So any questions on that? All right, so that just took a long time just because of the work we have to do. And it looks like we're going to have to do the work again. So let's practice one more time and then we'll call it a day. It is normally distributed using all three indicators. So we're going to do the same thing again. Well, that's dumb. All right, so the data represents the number of runs made each year during Bill Mazerisky's career. Check for normalcy. So what is our range? Okay, so what's 71 minus 3? 68. All right, we have to find a number between 5 and 20. So what's a number between 5 and 20? Between 5 and 20. 8, would 8 go into it? I don't think so. 64, yeah. I think this go around, I think for sake of argument, what if we say the range is 70? Right? Apparently it doesn't have to be perfect. So let's say this is about 70. And so 10 goes into 70, doesn't it? That'd be 7 times. Let's try something different. 7 goes into 70 and has a nice clean width of 10. So let's go with 7 classes. I mean, we could keep fighting this, but that part doesn't, I guess, really matter. So we'll start off with 3. So here's our classes. Here's our frequency. So I guess we have 3. So we want the width to be 10. So that'd be 3 plus 9, which is 12. And that gives us 10 numbers. You with that? Okay. And then it would be 13 plus 9, which would be 22. And then we get 14. Nope, I lied. 23 to 32. 33 to 42. 43 to 52. 53 to 62. And then 63 to 72. And 71 is the largest number. So there we go. Yeah, right. All right, so 3 to 12, I got 1. That's all I got. And then 13 to 22 would be 1, 2. I just got 2. 23 to 32. I don't have, I have 1. Oh, I didn't even see that first one. All right, so 2. 33 through 42. There's 1. 43 through 52. 1, 2, 3. 53 through 62. That's 1, 2, 3, 4, 5. And 63 through 72, I got 1, 2, 3. So I do my little histogram here. 1, 2, 3, 4, 5. My first one has 1. Then I got 2, 2, 1, 3, 5, and then 3. So do we think this one's skewed? Yeah, definitely going to be skewed to the right. And then the next part. To, yeah. No, it's a right skewed. It's a negative, left skewed, but negative skewed, right? Because it looks like it's on positive slope, but it's a negative. That's it. Left skewed, negative. Good luck on those tests. All right, the next part wants us to use the Pearson coefficient. Let's do that again. Oh gosh, we're gonna have to. Why don't they just give us the? All right, well, let's go calculate the standard deviation real quick. I'm gonna calculate all that. Perfect. All right, what was our numbers? You got 45.2 for the mean. You did? You guess that what you get? Yeah. Okay. Make sure I did it right. You're like, I got the right answer. I don't know about anyone else. Was it not 45? That's what the book got. Yeah. I don't like all these decimals. Then we got to square that. Then we got to find the sum. And then we got to divide that. Divided by, okay, this is a sample again. So this was, how many, was there 17 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 16. Yeah, because 9 plus 8 is 17. You're right. So that'd be 17 minus 1, which ends up being 16. And then we got to take the square root of that. What are you doing? Let's start off with an equal. Square roots of that answer gives us that. So we get 20.58. So when we bounce back over here somewhere, we get 3 times, what was it, 45, 2 minus, what was the median, which I calculate? It should be, yeah, 52. Should I put them in order, I guess? Oh, if you didn't know this, check this out. Median. You can ask the computer to do it for you. I don't know if you can just type in IQR. Let's see, IQR. No, I think you would have to maybe do Q1. Let's see, Q1. No, no. Or Also the data and then quartile number. Okay, so then I would want to do all of this data. Gerg. What is up with this? And I want, yes, I'm sure you could. All right, that's all I got for today. Sorry we didn't get time to do homework.